Welcome to the Passion for Technology podcast. In this episode, we're diving into an article from our latest TQ magazine, exploring the fascinating world of human-machine interfaces. For more details, interesting insights, and valuable infographics, be sure to check out the show notes. Full control in off-road machinery. In agricultural and construction machinery, the human factor is becoming even more central to human-machine communication. This means that the industry must increasingly rethink conventional operating concepts. The construction site of the future is a more connected place, and so-called gamification will play an important role. Demographic changes and consumer preferences are pushing our industry into areas that were previously unknown or underutilized in the machine sector, explains Vijay Shekhar Nerva, Head of Innovation and Acceleration at Doosan Bobcat EMEA. A clear example of this is the remote control via smartphone developed by Bobcat. This allows the operator to remotely control their compact loader within seconds without worrying about additional devices. Using a smartphone, the machine can be sent into a dusty or potentially unsafe environment to complete its tasks while the operator stays at a safe distance. The remote control communicates with the customer's iOS device via a Wi-Fi signal and operates within a range of up to 100 meters. The controls in the driver's cabin are also evolving. As land and construction machinery become more complex, touchscreens are increasingly being used in the off-road sector. They allow a variety of information to be called up and displayed in a targeted manner. With special die-cast housings and robust adhesive technologies, touchscreens can also withstand the inevitable shocks and vibrations in this area. The integrated PCAP touch provides optimal conditions for comfortable control of machine functions. PCAP stands for Projected Capacitive Touch. This technology turns a window or glass surface into a touch-sensitive interface, allowing users to interact as they are accustomed to from a tablet or smartphone with a touchscreen. Since the machine operator's visual and auditory senses are already heavily demanded in daily work, the company Elabao has developed a vibration module for joysticks. With certain vibration patterns, high-quality tactile feedback can be generated, making human-machine communication more efficient. The module's vibration motor is controlled by an electronics module via the CAN bus. Manufacturers can define different parameters such as intensity, duration, or number of vibrations via the CAN protocol. These parameters create individual, application-adapted, and above all intuitive vibration effects. Thus, the information content to be transported can be significantly increased compared to simple punctual knocking signals. With the multitude of functions that need to be operated in today's work machines, the control console can quickly become cluttered. The joint project AISA, abbreviated for Adaptive Interface Systems and Tractors, has presented itself as a promising solution. An adaptive armrest has been developed that only provides the functions of the attachment that is in actual use. Through the ISABUS, the intelligent operating armrest can adaptively adjust to any attachment as soon as it is coupled. It provides the user with an optimal and ergonomic interface in terms of position, availability, visualization, and operating mode. This includes, for example, a joystick that can assume 4 different positions depending on the required function. For example, it is retracted when its function is not needed. Other controls are provided via a rotary control unit. Each position adjusts depending on the attached work equipment and presents only the functions that are currently necessary. When working with construction and agricultural machinery, there are typically phases of both very high and relatively low stress. Various studies have shown that people's well-being is highest when there is a medium level of stress, says Professor Marcus Geimer from the Karlsruhe Institute of Technology. Overloading leads to the driver not being able to concentrate enough on the important aspects, overlooking things and becoming more prone to making errors. On the other hand, underutilization, for example through complete automation, is also a problem. The boredom that arises leads to fatigue and loss of concentration. As part of the Driver's Cab 4.0 research project, the Karlsruhe Institute of Technology is therefore developing an adaptable human-machine interface for agricultural machinery. It is capable of recognizing drivers' current stress levels via eye tracking. Research is also being conducted on a fitness bracelet that uses light signals to determine the pulse and thus measure the level of stress. If the system detects an overload, all unimportant information is faded out. In situations of underutilization, additional tasks should be offered to the driver. Meaningful additional tasks for phases of low stress come from accounting, personnel, or material management in the private task field, says Patrick Lair from the Institute of Mobile Work Machines at the Institute of Vehicle System Technology at the Karlsruhe Institute of Technology. In the future, the recommended task will be projected into the driver's field of vision via an augmented reality-based interface to avoid overloading the cabin with controls. We hope you enjoyed this episode. For more in-depth information on the latest trends and technologies in human-machine interfaces, check the show notes to access the latest TQ magazine, available free of charge.